sometimes you have to do something just to show that you can do it. When the Wright brothers flew for the first time, they flew an experimental aircraft. And in the same way, the Mars helicopter is designed to show that we can fly powered helicopter flight in the Martian atmosphere.
From day one, this was the unwavering dream of our team, to get our helicopter launched to Mars so that we can get that opportunity to do that very first rotorcraft flight test in the actual environment of Mars. It's extremely difficult to fly at Mars because the atmosphere is so thin. Compared to Earth, at Mars it's less than 1%. So the first and foremost challenge is to make a vehicle that's light enough to be lifted. And then the second is to generate lift. The rotor system has just been very fast. 2,000, 2,200, 2,400, 2,600. We're spinning between 2,000 and 3,000 revolutions per minute, and it takes a lot of energy. So it's that balance of a very light system, yet having enough energy that's needed to, spin the rotor so fast to lift, and on top of it, having to design in the autonomy.
It has to be fully autonomous from the time it takes off to the time it lands. What we do on the ground is we plan the flights, and so we determine from here where we want the helicopter to go.
Our experiment window is 30 Martian days. So we have planned up to 5 flights of incremental difficulty.
The very first flight, the main thing is we want to get the legs off the ground, and so we will basically go up about 3 meters, and we'll hover there, and then we'll come down again, and that will be the first, really major milestone.
Most of our flights will be at the 3 to 5 meter height. We will be going horizontally again at a few meters per second, probably go out, 50, 70 meters and come back. In successive flights, we'll probably push that further, try to go further. So our priority will be to get back engineering telemetry and not so much images, but I'm sure we'll return a few, because they'll always look cool.
At this point, we've tested all we can on Earth. We have mathematical models that shows how it'll fly at Mars, and we've tested it in the simulated environment that we can create on Earth. It really is time now to do the real flight test at Mars.
Nothing is a given, but we have done everything we can in terms of a test program here on Earth. The vehicle's performing extremely well so far. It's been doing exactly the right thing, even right now when it's bolted onto the Perseverance rover. So there's a very good chance that we'll pull it off, yes. But it's still high risk, and none of us forget that you could have a glitch that, could mean end of mission, yes.
It's going to be exciting, reacting to any surprises we have. We can't wait. What's really most important is everything we're learning here is for the future rotorcraft systems that we want to introduce into space exploration.
A safe return to Earth from the space station greeting the astronauts of the next commercial crew flight, and an update on development of a human lunar landing system. A few of the stories to tell you about this week at NASA. On April 16th, the International Space Station's Expedition 64 crew, including our Kate Rubins, closed out its time on the station. After saying farewell to those remaining on board the orbital outpost, Rubins, Sergei Ryzhikov, and Sergei Kutsverchkov, both of the Russian space agency Roscosmos, climbed aboard their Soyuz spacecraft and headed back to Earth. The trio touched down safely in Kazakhstan on the morning of April 17th after spending 185 days conducting research and maintenance aboard the space station. On April 16th, the astronauts for NASA's SpaceX Crew 2 mission to the space station arrived at our Kennedy Space Center for final pre-launch activities ahead of their flight to the station. Crew 2 is currently targeted for launch April 22nd from Kennedy's Launch Complex 39A.
We come in on the plane over here, and we got to fly by the pad and see our rocket getting ready to go, and it's just an amazing feeling. I've gotten to do that before, and there's nothing like it when you look out the window and see a spaceship getting prepared and realize that you're going to be riding on it in a few days.
Crew 2 is the second crew rotation flight of SpaceX's Crew Dragon spacecraft and the first with 2 international partners. The flight follows certification by NASA for regular flights to the space station as part of the agency's Commercial Crew program. Also on April 16th, NASA picked SpaceX to develop its commercial human landing system for the Artemis program. Their design was one of 3 competing for a crewed demonstration mission to the lunar surface. This system will help NASA complete the final leg of its lunar journey and land the next 2 American astronauts on the moon. Former NASA astronaut Pam Melroy has been nominated by President Biden to serve as the agency's deputy administrator. The nomination must be confirmed by the Senate. In a statement released in response to the nomination, acting NASA Administrator Steve Jurczyk said Melroy is a proven leader with a bold vision who is driven by a desire to solve the biggest issues here on Earth throughout the solar system and beyond. A veteran of 3 space flights and one of only 2 women to command a space shuttle, Melroy logged more than 38 days in space. Our Nancy Grace Roman Space Telescope will use gravitational microlensing to find thousands of new planets beyond our solar system. This quirk of gravity makes it possible to locate planets by observing how a planet's gravity distorts distant starlight. Turns out that because solitary small black holes known as stellar mass black holes produce the same effects, the mission will also provide the best opportunity yet to definitively detect these black holes for the first time. The Nancy Grace Roman Space Telescope is currently targeted for launch in the mid-2020s. April 12th marked the 40-year anniversary of STS-1, the first space flight of the nation's space shuttle program. On that date in 1981, NASA astronauts John Young and Bob Crippen launched aboard Space Shuttle Columbia on a 2-day test mission that began a new era of human spaceflight.
It allowed us to fly a diverse group of people into space to become astronauts. We didn't need just test pilots anymore. So it opened up the field of the astronauts in a much broader range than we'd ever had before.
STS-1 was NASA's first crewed mission since the Apollo-Soyuz test project in 1975. The launch also occurred 20 years to the day after cosmonaut Yuri Gagarin became the first human to orbit Earth on April 12, 1961. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/twan.
The importance of landing humans back on the moon is we're going back in a way that is totally different. We've had almost 60 years of experience, and we're taking every single ounce of experience we have and taking that with our international partners, with our commercial partners.
We've been working for the last year with 3 partners who will help us achieve the next human mission to the moon. Because we know that this first step to the moon will then lead us to go to Mars. And we know that the human landing system is one of the first steps to get us there. And so we've been working with Dynetics, Alido's company. We've been working with Blue Origin, who have partners of Draper, Lockheed Martin, and Northrop Grumman. In addition, we've also been working with SpaceX.
This is a very, very exciting time for the Human Landing System program. They've spent a lot of blood, sweat, and tears over this last couple years getting ready for this moment.
We're really excited to bring you the announcement of who NASA is going to continue to finish out the Human Landing System and take humans back to the moon. NASA has chosen SpaceX to return us to the moon. I am so excited to partner with SpaceX in this fantastic endeavor for the Artemis suite of missions. So congratulations to the SpaceX team.
The SpaceX design is a single-stage solution using their Starship. It provides extensive volume for the crew with 2 airlocks and ample down mass capability. The SpaceX proposal included in-space propellant transfer demonstration and uncrewed test landing.
So now that we've selected our partner, and for the next phase going forward, we have to make sure that the testing occurs, because we're not going to launch humans until we have a successful test. So we will be working to make sure that the design and everything that we have going forward so far is ready to go.
So the Human Landing System is going to allow us to be able to access different parts of the lunar surface. But it also allows us to explore a new technology and capabilities that will help us when we are trying to figure out our next round of technologies to be able to help us land on Mars or other planets out there.
I'd like to thank the companies for the great work this past year. We've all learned a lot. I'd like to thank the NASA team, because you have definitely risen to this challenge.
It is one more step and an exciting group of steps that will get us to a sustainable human landing system to the moon.
This budget shows President Biden's strong support for NASA and will enable us to achieve our ambitious goals across exploration, technology, aeronautics, and science.
Touchdown confirmed. Perseverance safely on the surface of Mars.
I received a call of congratulations from the President. He was so inspired by what we were able to accomplish.
Ready to begin seeking the sands of past life.
This budget allows NASA to address the climate change challenge in more significant ways than we've had in the past. It allows us to understand the Earth as a system, from the oceans to the atmosphere. The upcoming year is also going to be a very ambitious year for NASA and our programs. Aeronautics has been charged with developing a more environmentally friendly aviation system. One of them is the X-57 Maxwell flight demonstrator. Another really large milestone is the launch of the James Webb Space Telescope. It's going to enable amazing science research, including literally looking back in time. The administration early on expressed their strong support for the objectives of the Artemis program and our Moon to Mars plans. Which are the backbone of our exploration plans and our plans for Artemis.
Through the Artemis program, the United States government will work with industry and international partners to send astronauts to the surface of the moon.
We also have a robust robotic exploration program through the Commercial Lunar Payload Services activities with our commercial partners. The NASA workforce, our commercial partners, and our international partners should be really encouraged by this budget.
Here, ignition, liftoff.
NASA's exciting mission and missions inspire the nation, inspire the next generation of scientists, engineers, and explorers. And we will need that generation, including a diverse and more inclusive workforce, to be able to accomplish the ambitious goals that we've set out for NASA
We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Indicate chute deploy.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
LVS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
Here in safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
Preparing for first flight on Mars, making a splash with Orion, and the space station's next crew prepares for launch. A few of the stories to tell you about this week at NASA. Our Ingenuity Mars helicopter was the focus of a March 23rd briefing at our Jet Propulsion Laboratory in Pasadena, California. The Ingenuity team is targeting no earlier than April 8th for this technology demonstration to make the first attempt at powered controlled flight of an aircraft on another planet.
We use drones and helicopters here on Earth for all sorts of things that they're more suitable for than land-based vehicles, right? So you can just imagine being able to have that same capability on Mars, flying around on Mars. And that could be for reconnaissance purposes, taking pictures to scout out areas, potential science targets for future rovers or even future astronauts.
Once deployed from the Perseverance rover, Ingenuity will have 30 Martian days, equal to about 1 month here on Earth, to conduct its test flight campaign. Engineers at our Langley Research Center are using a test version of our Orion spacecraft for water impact testing. During the tests, the crew module is dropped into a large pool of water to learn more about what the spacecraft and astronauts inside might experience while landing in the Pacific Ocean after missions to the Moon. Data from the drop tests will be used for final computer modeling for loads and structures prior to Artemis II, our first Artemis mission to the Moon with astronauts. The International Space Station's next crew, including our Mark Vande Hei, completed pre-launch qualification exams and participated in various other activities in and around Moscow, Russia. Vande Hei and Oleg Novitsky and Pyotr Dubrov of the Russian space agency Roscosmos will complete their pre-flight training at the Baikonur Cosmodrome in Kazakhstan ahead of their targeted April 9th launch to the space station. The Lockheed Martin team building our X-59 quiet supersonic technology aircraft recently merged its empennage to the wing. The empennage is the section that supports the experimental plane's engine and tail. NASA is targeting 2022 for the first demonstrations of the X-59's ability to create a soft thump during supersonic flight instead of the typically loud sonic boom. NASA has contracted California company Crystal Instruments to deliver a state-of-the-art ground recording system capable of capturing the acoustic data needed before test flights over communities around the U.S. can begin. Those flights could start as early as 2024. Data from the NASA and U.S. Geological Survey's Landsat 8 and other satellites are helping scientists identify algal blooms in lakes or rivers. These naturally occurring blooms can make these bodies of water harmful for recreational use. The Landsat 8 data is used to create a product that can help local water or recreation managers identify areas where a potential problem exists. According to a 2020 study published in the journal GeoHealth, Landsat-based detection of a 2017 bloom in Lake Utah helped save an estimated $370,000 in healthcare and related costs for that area. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/twan. How it looks to land on Mars, previewing space station spacewalks, and supplies and cargo delivered for the station crew. A few of the stories to tell you about this week at NASA. Newly released high-definition videos captured by cameras onboard our Mars 2020 Perseverance rover show the final 7 miles of the spacecraft's entry, descent, and landing on Mars. The uniquely amazing views, including the look down at the separation of the protective heat shield and the upward views during deployment of the most massive parachute ever sent to another world,
are the closest you can get to landing on Mars without putting on a pressure suit.
While a microphone on the rover did not collect any usable data during the landing after Perseverance touched down, it did pick up mechanical sounds made by the rover operating on the surface and even a few audible seconds of a Martian breeze. Also released with the videos and audio was the first panorama of the rover's landing location taken by the 2 navigation cameras on its mast. These were all followed up 3 days later with the release of the rover's first complete high-definition look at its surroundings, a 360-degree panorama from its Mast Cam Z instrument. Perseverance will use its suite of instruments to search for signs of past microbial life, collect and leave samples of rock and soil for our future mission to bring back to Earth, and test technologies to help pave the way for future human exploration of Mars. Find out more at nasa.gov/perseverance. We previewed 2 International Space Station spacewalks during a February 24th briefing at our Johnson Space Center. During the first spacewalk on February 28th, our Kate Rubins and Victor Glover will prep for solar array upgrades later this year. Rubins will then go back outside on March 5th with Japan's Soichi Noguchi to vent ammonia from the station's thermal control system along with other tasks. The Northrop Grumman SS Katherine Johnson Cygnus cargo spacecraft arrived at the space station February 22nd, 2 days after launching from our Wallops Flight Facility. It delivered about 8,000 pounds of scientific research, crew supplies, and hardware to the station. The spacecraft is named after late NASA mathematician Katherine Johnson, one of the women featured in the book and movie Hidden Figures, who made significant technical contributions to some of NASA's earliest and most historic space flights. On February 26th, our NASA headquarters building in Washington, D.C. was officially named in honor of Mary W. Jackson, the agency's first African-American female engineer, who was also featured in Hidden Figures. Acting NASA Administrator Steve Jerzik led the ceremony, joined by Jackson's family and other special guests, with the on-site attendance limited due to the ongoing coronavirus pandemic.
3, 2, 1.
The ceremony featured the unveiling of a building sign with Jackson's name and several video tributes, including poet Nikki Giovanni reading from her poem Quilting the Black-Eyed Pea, which is about space and civil rights. Learn more about the contributions of Jackson, Katherine Johnson, and other NASA hidden and modern figures at nasa.gov/modernfigures. Our Parker Solar Probe captured some surprising views of Venus during a close flyby in July 2020. The image shows Aphrodite Terra, the largest highland region on the Venusian surface. The team is surprised because, based on the imaging device's capabilities, they only expected to see clouds, not clear down to the planet's surface. They are now trying to determine if the imager has unforeseen capabilities, which would provide new opportunities to study dust around the Sun and in the inner solar system. The mission focuses on the Sun, but it makes several passes of Venus using the planet's gravity to help it fly closer and closer to the Sun. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/twan.
You've seen weird, wonderful worlds in science fiction. We don't yet know what sorts of life might exist out there, but some of the planets, not unlike the ones in your favorite stories, are real. At NASA, we're studying them. They're called exoplanets. The term exoplanet means a planet outside our solar system, a planet that doesn't orbit our sun. Most orbit other stars, but some are just sunless wanderers out in the space between the stars. Now, just the fact that they orbit other stars means exoplanets are extremely far away. Most are too far to even dream of sending space probes to explore them. So we study them in other ways, like with telescopes on the ground and in space that can observe these far-off planets from right here in our solar system. Here's the thing about exoplanets. They are everywhere. In fact, from our observations so far, we know there are more planets than stars. So, there's our solar system, then there are all the billions of planetary systems in our galaxy, the Milky Way. Then there are all the billions of other galaxies. Basically, there are a lot of exoplanets out there. Each of the stars you see in the night sky is the sun for any planets that orbit around it. But not all stars are created equal. Bigger stars burn way brighter and hotter and don't last as long. Smaller, fainter stars like our sun and red dwarf stars last much longer. But even nice, cool red dwarf stars can have powerful flares that blast their planets with radiation. We're still trying to understand which kinds of stars provide long-lasting, stable conditions that could allow life a chance to take hold and evolve like it did here on Earth. Exoplanets are super hard to see, both because they're so far away and because they're so much fainter than their stars. But we've worked out some clever methods to detect them and even take pictures of some. So, what can we observe? Well, for many, we can determine their size, their mass, how much they weigh, and how far away from their stars they orbit. From these and a few other clues, we can infer a bunch of other qualities, like how hot or cold it might be on their surfaces, or if they even have surfaces. We can tell that some are gas giants like Jupiter, while others are like bigger, bulkier versions of Earth. For some, we can determine they have atmospheres, and even some of the gases in those atmospheres. Most exoplanets are very different from our planet. They have a lot of weird, wild variety, with gas giants much bigger than our own Jupiter, and other planets with oceans of lava, or rainy glass, or even gemstones. Funny thing is, looking at how they're arranged as families of planets, we don't see a lot of exoplanet systems that look like ours so far. Many are arranged quite differently, so we might actually be the weird ones. Some planets are closer to their stars, some are super far. Some even orbit multiple stars. Imagine having 2 or 3 suns in the sky. So why do we study exoplanets? Well, our interest in finding worlds with life on them is a big factor. We want to know more about what makes a planet a place with all the right ingredients and conditions for life, what scientists refer to as habitability. How does it happen? How common is it? We think the most life-ready planets are the ones most similar to Earth, with a range of qualities that include similar size and composition to our planet, and being at the right distance from their stars to have liquid water on the surface. These qualities are really challenging to observe from so far away, but we're working on it. Exoplanets teach us a bunch of other things too. Studying other planetary systems helps us better understand the story of our own planet family, including Earth. Scientists detected the first exoplanets in the 1990s, but now we're finding tons more, thousands so far. We're studying their atmospheres and even making weather maps for some. We're surveying exoplanets to understand all their variety. And the more we learn, the more it powers our curiosity, the more we want to explore exoplanets, planets outside our solar system. You've seen weird,
How it looks to land on Mars, previewing space station. Cargo delivered for the station crew. A few of the stories to tell you about this week at NASA. Newly released high-definition videos captured by cameras onboard our Mars 2020 Perseverance rover show the final 7 miles of the spacecraft's entry, descent, and landing on Mars. The uniquely amazing views, including the look down at the separation of a protective heat shield and the upward views during deployment of the most massive parachute ever sent to another world,
are the closest you can get to landing on Mars without putting on a pressure suit.
While a microphone on the rover did not collect any usable data during the landing after Perseverance touched down, it did pick up mechanical sounds made by the rover operating on the surface and even a few audible seconds of a Martian breeze. Also released with the videos and audio was the first panorama of the rover's landing location taken by the 2 navigation cameras on its mast. These were all followed up 3 days later with the release of the rover's first complete high-definition look at its surroundings, a 360-degree panorama from its mast cam Z instrument. Perseverance will use its suite of instruments to search for signs of past microbial life, collect and leave samples of rock and soil for our future mission to bring back to Earth, and test technologies to help pave the way for future human exploration of Mars. Find out more at nasa.gov/perseverance. We previewed 2 International Space Station spacewalks during a February 24th briefing at our Johnson Space Center. During the first spacewalk on February 28th, our Kate Rubins and Victor Glover will prep for solar array upgrades later this year. Rubins will then go back outside on March 5th with Japan's Soichi Noguchi to vent ammonia from the station's thermal control system.
step per man, 1 giant leap for mankind.
At number 7, we have the Mars Trio missions. 3 countries launched their Mars mission in 2020 and all 3 have reached the Mars. Let's take a look at all the 3. First, on 9th February, the UAE's Hope probe arrived and began orbiting the planet in order to study its atmosphere and weather. It was launched from Japan last year on 19th July, which made UAE the second country to successfully enter the Mars orbit at its first time after India, which achieved this with the Mars Orbiter mission back in 2014. Hope probe is an orbiter which will study daily and seasonal weather cycles, weather events in the lower atmosphere such as dust storms, and how the weather varies in different regions of the planet. Its mission is to study the atmospheric layers of Mars in detail and provide data to study the reason for a drastic climatic change in the Martian atmosphere from the time it could sustain liquid water to today. When the atmosphere is so thin, water can exist only as ice or vapor. To help understand how and why Mars is losing its hydrogen and oxygen into space, and the connection between the upper and lower levels of the Martian atmosphere leading to planet's drastic climatic changes. This mission's duration is planned to be around 2 years. Second, a few days later, China's Tianwen-1 orbiter arrived to look for a potential landing site before depositing a lander on the surface a couple of months later. It was launched on 23rd July of last year from China and was inserted in Mars orbit on 10th February of this year, around the same time as that of the Hope probe. This is China's first interplanetary mission as well as its first independent probe to Mars. The goal is therefore, first of all, to validate the communication and control technologies in deep space, the placing in orbit around the planet, and the landing on its surface. The orbiter must also make it possible to locate a site for a future return of Martian samples. The scientific objectives of the mission relate to the geology of Mars, the current and past presence of water, the internal structure of the planet, the identification of minerals and different types of rocks on the surface, as well as the characterization of the space environment and atmosphere of Mars. The mission will attempt to land its rover on Mars in May 2021. If all goes well, then China will become the second country to have a rover on Mars after the USA, and third country to soft land on Mars, the second position taken up by the Soviet Union. Even this mission will be operational for 2 years. Third, which we recently witnessed in the last month, NASA's Mars 2020, which released its Perseverance rover on 18th of February to search for signs of microbial life and drill for rocks that could be returned to Earth by a future mission. The Perseverance was launched from Cape Canaveral on 30th July 2020 and was deployed on the Mars successfully with all the systems with a healthy status. The Perseverance rover has 4 science objectives that support the Mars exploration program's science goals. First, looking for habitability. Identify past environments that were capable of supporting microbial life. Second, seeking biosignatures. Seek signs of possible past microbial life in those habitable environments, particularly in specific rock types known to preserve signs over time. Third, caching samples. Collect core rock and regolith soil samples and store them on the Martian surface. Fourth, preparing for humans. Test oxygen production from the Martian atmosphere. And also, they are gearing up for the first flight on the planet with the Ingenuity helicopter. It is a technology demonstration to test the first powered flight on Mars. Once the rover reaches a suitable helipad location, it will release Ingenuity to perform a series of test flights over a 30 Martian day experimental window beginning sometime in the spring. The helicopter cannot be controlled by a joystick as communication delays are an inherent part of working with the spacecraft across interplanetary distances, hence full autonomy is important. These were the 3 missions which are presently active in Mars. Moving on, at number 6, we have the Luna 25 mission. Luna 25 is a planned lunar lander mission by Roscosmos which will land near the lunar south pole. Initial mission plans called for a lander and orbiter, with the latter also deploying impact penetrators. In its current form, Luna 25 is a lander only, with a primary mission of providing out the landing technology. The mission will carry 30 kg of scientific instruments, including a robotic arm for soil samples and possible drilling hardware. The last mission Russians launched to the moon was Luna 24 in 1976. Perhaps in response to the rapid development of NASA's Artemis program and China's lunar exploration program, Russia has resurrected the Luna program with the 25th planned mission, which is scheduled for launch in October. Luna 25 will be a lander that heads to the lunar south pole. It will test out a new kind of landing technology that Russia plans to use for future robotic missions, but the lander also carries a suite of scientific instruments that will study the moon's soil. The mission will use Soyuz 2 rocket and it is scheduled for launch on 21st of October. Next, at number 5, we have the end of Juno. Is it? Juno, short term for Jupiter Near Polar Orbiter, was launched on 5th August 2011 from Cape Canaveral, and it reached its destination, which is the planet Jupiter, on 5th July 2016. Juno's mission is to measure Jupiter's composition, gravitational field, magnetic field, and polar magnetosphere. It will also search for clues about how the planet formed, including whether it has a rocky core, the amount of water present within the deep atmosphere, mass distribution, and its deep winds, which can reach speeds up to 620 km per hour. Since 2016, Juno has been orbiting Jupiter and providing best data yet about the Jovian atmosphere, of its gravitational field, magnetic field, and geology. Juno has shown us some surprising things about our solar system's biggest planet, as well as provided some breathtaking views of the planet's vibrantly colored clouds from above. The mission was supposed to end on July 30th of this year, but there were talks in the agency to extend the mission to September 2025 so that Juno can do flybys of some of the Jupiter's moons and study them up close. Then guess, in the year 2025, Juno will plunge into Jupiter's atmosphere, collecting as much as data possible before violent pressures tear the spacecraft apart. Perhaps that violent ending might be put on hold for a few more years until 2025. Moving on, at number 4, we have the James Webb Space Telescope. The James Webb Space Telescope is a joint NASA, ESA, and CSA space telescope that is planned to succeed the Hubble Space Telescope at NASA's flagship astrophysics mission. Named after James E. Webb, who was the administrator of NASA from 1961 to 1968 and played an integral role in the Apollo program. This telescope will have a diameter of 6.5 meters and focal length of 131.4 meters. Its nominal mission time is 5 years with a goal of 10 years. The JWST will be located near the second Lagrange point of the Earth-Sun system, which is 15 lakh kilometers from Earth, directly opposite to the Sun. So why is working with infrared an advantage? The answer is that infrared radiation can pass more freely through regions of cosmic dust that scatter visible light. Observations in the infrared allow the study of objects and regions of space which would be obscured by the gas and dust in the visible spectrum, such as the molecular clouds where stars are born, the circumstellar disk that give rise to planets, and the core of the active galaxies. Relatively cool objects, temperatures less than several thousand degrees, emit their radiation primarily in the infrared as described by Planck's law. As a result, most objects that are cooler than stars are better studied in the infrared. This space telescope will provide improved infrared resolution and sensitivity over Hubble and will enable a broad range of investigations across the fields of astronomy and cosmology, including observing some of the most distant events and objects in the universe, such as the formation of the first galaxies. This NASA telescope, which is to replace the Hubble, has been subject to many delays. Its first planned launch was in 2007. A March 2020 takeoff was delayed due to COVID, while its initial $500 million budget has spiraled to more than $10 billion. It is a more sensitive telescope than the Hubble, and once operational, it will be able to observe the formation of some of the first galaxies. It will be launched on a European Ariane 5 rocket on 31st of October. Get ready to get the pictures of the universe with better resolution. Next, at number 3, we have the Artemis 1. Artemis 1, initially named as Exploration Mission 1, is the first in a series of increasingly complex missions that will enable human exploration to the Moon and Mars. It will be the first integrated flight test of NASA's deep space exploration systems, the Orion spacecraft, Space Launch System, with the newly upgraded exploration ground systems at Kennedy Space Center in Cape Canaveral, Florida. Artemis 1 will be uncrewed lunar orbital test flight, which will be launched from Kennedy Space Center in November of this year. This test comes prior to the crewed mission, as the Orion spacecraft will be sent on a mission of 25.5 days, 6 of those in a retrograde orbit around the Moon. The mission will certify the Orion spacecraft and Space Launch System rocket for crewed flights, beginning with the second flight test of the Orion and Space Launch System, Artemis 2, which will carry a crew of 4 around the Moon in 2023 for a week-long mission and back prior to the assembly of the Gateway. The primary operation goals of the mission is to assure a space crew module entry, descent, splashdown, and recovery. In addition to sending Orion on its journey around the moon, SLS will carry 13 small satellites that will perform their own science and technology investigations. The first in a series of increasingly complex missions, Artemis 1 will provide a foundation for human deep space exploration and demonstrate our commitment and capability to extend human existence to the moon and beyond prior to the first flight with the crew on Artemis 2. We must learn how to sustain human life in the extreme environment of space at the moon in preparation for human missions to the Mars. Moving on, at number 2 we have the DART mission. DART, which stands for Double Asteroid Redirection Test, is a planned space probe that will visit the double asteroid Didymos and demonstrate the kinetic effects of crashing an impactor spacecraft into an asteroid moon for planetary defense purposes. The mission is intended to test whether a spacecraft impact could successfully deflect an asteroid on a collision course with the Earth. This mission is to be launched from Vandenberg, which is a United States Space Force base, on 24th November 2021 from a SpaceX Falcon 9 rocket. After separation from the launch vehicle and over a year of cruise, it will intercept Didymos moonlet in late September 2022 when the Didymos system is within 11 million kilometers of Earth, enabling observations by ground-based telescopes and planetary radar to measure the change in momentum imparted to the moonlet. That would then impact the asteroid's moon in October 2022 during a close approach to Earth. As said, it is a planetary defense-driven test of technologies for preventing an impact of Earth by a hazardous asteroid. That will be the first demonstration of the kinetic impactor technique to change the motion of an asteroid in space. The mission's target is 65803 Didymos, a binary asteroid system in which one asteroid is orbited by a smaller one. The primary asteroid, called Didymos A, is about 780 meters in diameter, and its small satellite Dimorphos Didymos B is about 160 meters in diameter in an orbit about 1 kilometer away from the primary. DART will target the smaller asteroid Dimorphos, which is called as Didymos B, and Didymos is not an Earth-crossing asteroid, and there is no possibility that the deflection experiment could create an impact hazard. The DART spacecraft will achieve the kinetic impact deflection by deliberately crashing itself into the moonlet at a speed of approximately 6.6 km per second with the aid of an onboard camera and sophisticated autonomous navigation software. The collision will change the speed of the moonlet in its orbit around the main body by a fraction of 1%, but this will change the orbital period of the moonlet by several minutes, enough to be observed and measured by the telescopes on Earth. Which brings us to the number 1 mission, which is a much awaited launch for Indians. At number 1, we have the Gaganyaan mission. Gaganyaan, Indian crewed orbital spacecraft intended to be the formative spacecraft of the Indian human space flight program. Gaganyaan crew module is a fully autonomous and spacecraft is being designed to carry three people, and a planned upgraded version will be equipped with rendezvous and docking capability. In its maiden crewed mission, with its largely autonomous 3.7-ton capsule will orbit the Earth at 400 km altitude for up to 7 days with a 2 or 3 person crew on board. The crewed vehicle was originally planned to be launched on ISRO's GSLV Mark III in December 2021, but this has since been delayed to the year 2023. This Hindustan Aeronautics Limited manufactured crew module had its first uncrewed experimental flight on 18th December 2014. The Indian Space Research Organization's pad abort test was conducted successfully on 5th of July 2018. The latest push for the Indian human spaceflight program took place in 2017, and it was accepted and formally announced by the Prime Minister Narendra Modi on 15th August 2018. The current design calls for a crew of 3. ISRO will perform 4 biological and 2 physical science experiments related to microgravity during the Gaganyaan mission. As of May 2019, design of the crew module has been completed. Defense Research and Development Organization DRDO will provide support for critical human-centric systems and technologies like space-grade food, crew healthcare, radiation measurement and protection, parachutes for the safe recovery of the crew module, and fire suppression systems. The final crewed Gaganyaan mission is aimed at sending astronauts to space in an orbital spacecraft. 4 Indian officers who were selected to become astronauts to crew Gaganyaan into orbit were sent to Russia for 1-year training on 10th of February 2020 and have completed their 1-year training course. On 11th June 2020, it was announced that while the first uncrewed Gaganyaan launch has been delayed due to COVID-19 pandemic, overall timeline for the crewed launches is expected to remain unaffected. Thank you so much for staying till the end. let's hope all the missions are on schedule. So this makes up a total of 7 missions for this year, which are major missions which can't be missed. We'll keep you updated. That's the end of this video. Please like the video and subscribe. Also please share it with your close ones and make sure you follow on these platforms to never miss an update. Meet you guys in the next video. Till then, take care and keep enjoying. Thank you.
Welcome to NASA's Jet Propulsion Laboratory in Southern California. NASA's Ingenuity Mars helicopter hitched a ride to the Red Planet on the Mars 2020 Perseverance rover, which landed in Jezero Crater on February 18th. Earlier today, Ingenuity should have autonomously performed its first flight attempt on Mars. Now the team is ready to receive the data that will tell them whether we've made history with the first controlled flight on another planet. Thank you for joining us at this early hour. I'm Marina Jurica of the JPL News Office. Ingenuity is a technology demonstration, which means it is a proof of concept experiment. After years of development on Earth, the team has 1 month to test the technology on Mars. Tonight, we'll talk to a few team members and then keep our eyes on the room where the helicopter operations team will be receiving and studying their data. To assist us in that room is one of the Ingenuity helicopter engineers, Taryn Bailey, who will help guide us through the steps the helicopter team is taking to see the results of their first flight and begin the month of Ingenuity. Welcome, Taryn.
Hi, Marina. Thanks so much for having me. Super excited to be here. It's flight night. Woo!
Yes, it's flight night. You had an integral part with the helicopter team. Can you tell us about your role?
Yeah, so I'm a mechanical engineer, and I helped in the assembly, integration, and testing of the Ingenuity vehicle. And it was really important that we simulate a Mars-like atmosphere in our testing. And in doing so, we knew it would give us the best chance to execute a real flight on Mars.
And that's not an easy feat. Flying on Mars is much different than flying on Earth.
Very difficult. It's less than 1% of Earth's atmosphere, making it very difficult to fly and generate enough lift.
So, Taryn, what is the Ingenuity team preparing for right now? What are they waiting to see?
We're waiting to see data confirming that we executed our first flight. The actual flight on Mars took place earlier today, and that's because Mars is over 178 million miles away, so there's a little bit of a delay. The data is expected to hit the Deep Space Network at about 3:34 a.m. Pacific time, and we'll start processing the data shortly after that to see how we did.
Fingers crossed. Thanks so much, Taryn. We'll be coming back to you shortly as we get closer to the start of the data downlink. What started out as a dream is now becoming reality for the Ingenuity helicopter team. Let's take a look at their journey.
Sometimes you have to do something just to show that you can do it. When the Wright brothers flew for the first time, they flew an experimental aircraft. And in the same way, the Mars helicopter is designed to show that we can fly powered helicopter flight in the Martian atmosphere.
From day one, this was the unwavering dream of our team, to get our helicopter launched to Mars so that we can get that opportunity to do that very first rotorcraft flight test in the actual environment of Mars. It's extremely difficult to fly at Mars because the atmosphere is so thin. Compared to Earth, at Mars it's less than 1%. So the first and foremost challenge is to make a vehicle that's light enough to be lifted. And then the second is to generate lift. The rotor system has just been very fast. 2,000, 2,200, 2,400, 2,600. We're spinning between 2,000 and 3,000 revolutions per minute, and it takes a lot of energy. So it's that balance of a very light system, yet having enough energy that's needed to spin the rotor so fast to lift, and on top of it, having to design in the autonomy.
It has to be fully autonomous from the time it takes off to the time it lands. What we do on the ground is we plan the flights, and so we determine from here where we want the helicopter to go.
Our experiment window is 30 Martian days. So we have planned up to 5 flights of incremental difficulty.
Very first flight, the main thing is we want to get the legs off the ground, and so we will basically go up about 3 meters, and we'll hover there, and then we'll come down again, and that will be the first, really major milestone.
Most of our flights will be at the 3 to 5 meter height. We will be going horizontally again at a few meters per second, probably go out, 50, 70 meters and come back. In successive flights, we'll probably push that further, try to go further. So our priority will be to get back engineering telemetry and not so much images, but I'm sure we'll return a few, because they'll always look cool.
At this point, we've tested all we can on Earth. We have mathematical models that shows how it will fly at Mars, and we've tested it in the simulated environment that we can create on Earth. It really is time now to do the real flight tests at Mars.
Nothing is a given, but we have done everything we can in terms of a test program here on Earth. The vehicle's performing extremely well so far. It's been doing exactly the right thing, even right now when it's bolted onto the Perseverance rover. So there's a very good chance that we'll pull it off, yes. But it's still high risk, and none of us forget that you could have a glitch that, could mean end of mission, yes.
It's going to be exciting, reacting to any surprises we have. We can't wait. What's really most important is everything we're learning here is for the future rotorcraft systems that we want to introduce into space exploration.
Along with your cup of coffee, you can join in on the conversation by asking the helicopter team questions at NASA JPL on all social platforms by using the hashtag MarsHelicopter. We will get to your questions later on in the program. Mimi Ong is the project manager for Ingenuity. She joins us now as they wait for the downlink to start. Welcome, Mimi. Good morning.
Hi, good morning, Marina.
Now, Mimi, this has been quite the journey for you and your team. How do you feel finally reaching this moment?
Our team has been working on the Mars helicopter for over 6 years, and for some even longer, towards this ultimate dream of experimenting the first flight at Mars. Here we are.
Yes, here we are. And last week was a little bit of a week for you guys. You've had some technical challenges. What made you decide to go ahead with the first flight attempt this morning?
April 9th was a surprise. We were 2 days away from first flight and just onto our very last checkout. High-speed spin of the rotor system. And there we discovered an intricate timing issue that was preventing the helicopter from transitioning to flight mode, the mode that we need to be in to spin the rotor system high speed. So right after we found that, our team went into high gear, identified 2 possible solutions in a couple of days, and we picked the solution that is really the most simple, most straightforward option. So a note there, though, that the solution that we have adopted, it does transition to the helicopter into flight mode about 85% of the time. So when we go to flight, and if we don't go into flight mode, the helicopter will stay safe, and we will attempt the first flight again. So just last Friday, we took this solution, applied it to Ingenuity, and successfully spun Ingenuity's rotor system full speed. So next step is our first flight attempt now.
And to give folks at home, Mimi, some perspective, the goal is to fly on a planet that has just 1% the atmosphere of Earth. And you're controlling that flight from over 100 million miles away. How difficult is that?
Very, very difficult to fly a rotorcraft at Mars. A rotorcraft pushes the atmosphere to generate lift. And when there is that little atmosphere, the rotor system has to spin really fast. In fact, we'll be spinning over 2,500 revolutions per minute for this flight today. And Ingenuity is less than 1.8 kilograms, right? 4 pounds. And in that 4 pounds, Ingenuity has to be able to fly in that very thin atmosphere and be able to survive and operate autonomously at Mars. For example, Ingenuity, our little 4-pounder, has been on the surface of Mars, keeping itself warm throughout the cold nights, down to minus 130 degrees Fahrenheit, and it's been doing that every day. So on top of that, our flight experiment at Mars, we are operating it all the way back here from Earth. So yeah, it's very challenging, but we're ready.
Oh, Ingenuity is small, but it is mighty, and the team has come so far already. What other milestones has the helicopter team already achieved before this morning?
Ingenuity has passed all of its milestones leading up to the first flight. So performed perfectly during cruise, survived the drop, and has been charging itself with high good energy levels. Each time it's been communicating daily to the base station and keeping itself warm. And with the rotor system all checked out to full speed, Ingenuity is ready to go. And at the high level for the Mars helicopter technology project, we have 3 goals that are in line with NASA's agency level objectives. The first is to demonstrate here on Earth that it is possible to fly a controlled power flight in the thin atmosphere of Mars. We've done that. The second objective is to perform that actual flight at Mars. Well, we're about to get data back very soon here on that first flight. And the third is to return data to inform engineers working on designing future generations of Mars helicopter. We have received valuable information data back since we have dropped on the surface. And tonight's data from the first flight will be extremely important. So we're ready to go.
We are ready to go. Now, what is success going to look like for you guys tonight?
So there are 5 scenarios. Okay, so if the solution we implemented successfully transitions the helicopter to the flight mode, we'll be all right. But if it doesn't transition, then we will be attempting the flight again tomorrow. If we don't get to flight mode tonight, then we'll go on. If we go successfully to the flight mode, there are 4 scenarios. Full success in flight. Second scenario could be partial success in flight. The third would be not having sufficient information, in which case we'll need more time to determine what happened. The fourth could be failure. So whatever the outcome, we are set here to learn.
And a bright future is ahead, Mimi. The risk is huge, but the reward is high. We will all be rooting for your team. Good luck.
Thank you, Marina.
As we get closer to the data arrival, let's talk to Tim Canham, Ingenuity Operations Lead. Thanks for joining us, Tim.
Thanks, Marina. Glad to be here.
Now, how does the data even get here from the helicopter to the team?
Well, as they say, sometimes it's complicated, right? So the
Welcome, guys. Yeah, I was just testing my mic. So welcome back to the Lighted Sky live stream for Ingenuity flight. So the team is waiting for the data, and they are yet to receive because there's a 20-minute gap, so the communications will happen after like 20 minutes. We will set the signal, it will send the signal back after 20 minutes. So we are waiting for that all the data to come back. And we just heard from the head that the Ingenuity is in good condition. It is sending the data very like healthy status, and also it is keeping itself warm because it had to survive the cold night of Mars and all. So currently everything is good and they are good to go. So we are waiting for that confirmation. If you have anything to ask, you can put down in the chat box. I will try to answer that. Thank you.
For right field, and we found it fortunately right near where we landed. And so working with other instruments on the rover, like Meta with the weather instrument and Z-Cam, which is this beautiful camera to take pictures, we planned our flight. The flight will be about 40 seconds long. We'll lift off, we'll pivot towards the rover, and then we'll land. It's going to be a very basic flight. We want to do the very basic things first to make sure that we can do our flight. And then at that point, we will get all our data back and look at it. But we had to practice all those things. And we've been using this time on the surface to get familiar with the vehicle and how it operates and work around those various troubles that Mimi talked about. And the team is ready to go.
And Tim, what specifically will the helicopter team be looking for as we go through this morning?
So one of the great things about this helicopter is it has a very powerful processor. It's tiny, but it's powerful, and we get lots and lots of data. The processor itself is about 100 times as powerful as the processor, even on the rover. And so we get all this data, as I mentioned, that gets sent to the rover, and then the rover sends it to us. So as our downlink lead, Michael Starch, sees that data arrive in the data center, he will decode it and look for the successful arrival of the data. At that point, we turn the data over to Hovard Grip, our chief pilot, and he will look at the portion of the data that relates to how the flight went. There are a series of events that the helicopter sends as it transitions through each stage of the flight. And when Hovard is able to verify that the progression went as planned, then he'll turn to the actual data and look at a plot of the altimeter, which is one of the instruments used in navigation, we should see the plot of the altimeter go up to the flight height and then come back down again. And that will be a positive confirmation that we got it. And finally, from the helicopter side, we are snapping a series of black and white downward facing pictures as the helicopter comes in for landing. So if everything goes well, we should see some of those landing pictures and be able to look at them on the screen. So Hobart will display those as well. And then finally, if all goes well, there should be, at the same time our data is coming down, there should be data coming down from the Z-Cam instrument that I mentioned, the Mastcam Z, a really powerful camera system that's going to try to capture us in flight. So if they were able to capture that moment of flight, then they will be able to display those images on their screen and be able to see a quick view of how the helicopter flew. That's how it's going to go.
Well, Tim, we can't wait to see those photos for sure. Thank you so much, and good luck to you.
Thank you.
We will get back to the action in the room in just a moment. Now joining us is Associate Administrator of NASA's Science Mission Directorate, Thomas Zurbuchen, who is here at JPL for the helicopter's first test flight. Welcome, Thomas.
I'm so glad to be here, Marina. Hi.
Hi. Now, how important is tonight to space exploration?
Oh, it's technology demonstrations are really important for all of us. You know, it's really taking a tool that we haven't been able to use and put it in the box of tools that is available for all of our missions going forward at Mars. So for me, it's really exciting personally, and for the community overall, it opens up new doors.
And Thomas, why is it important to have that aerial dimension to space exploration?
So guys, as you heard from the guy, so it is like we'll get a set of data from the helicopter from the Mars orbiter there, and a flight technician will see the data. He will see for some particular data, like if you look at that, he will get to know that if how did the flight perform. So they're waiting for that data. So let's stay tuned from them.
From the very beginning, so we have such great leadership on this team, and very excited to be here.
And we're going to be hearing from a lot of people, Taryn. So can you let us know who we're going to be hearing from as we progress through the morning?
Yes, so we'll first hear from our downlink lead, Michael Starch, and he's going to be the person that first lays eyes on the data. And when he receives it, he'll unpack it, he'll run through a data receival procedure, make his call outs, and then he'll hand it over to our guidance, navigation, and control lead, also our chief pilot, Havard Grip. He'll interpret that data and display an altimeter plot to indicate if we flew. Some other voices we'll hear on VOCA will be our deputy ops lead, Teddy Zenetos, who will report on the battery status, and our systems engineer, Jaco Karas, who will report on the motor health.
And we're going to be taking a couple of your social media questions right now as we wait for Michael to make that announcement that the data is coming in. So, Taryn, a man named Flo on Instagram asks, why did we send a helicopter to Mars in the first place?
Great question. Why not? Just kidding. Sending an aerial vehicle at this stage especially, we have sent 5 rovers to Mars, and now we have an aerial dimension, which Dr. Zurbuchen pointed out that it's really important because it elevates the next stage of space exploration. And we can do more science with it. It can be a coordinated effort for future missions. It also opens the doorway for human exploration, and the helicopter can go into areas where the rover can't. So there are a lot of caves and the rover has to overcome a lot of obstacles on the ground that the helicopter can ideally move around. And that's why it's such a great option for putting an aerial vehicle on another planet.
And as Tim mentioned, it has to be well choreographed, this flight. And so Elio on Instagram asks, why is the first flight only vertical?
So every flight, we're going to build upon it. But this first flight, our mission success criteria is really to demonstrate that we can fly. And so that's why this first flight is really all about being able to demonstrate that we can fly on another planet. And so that means we'll do a 3-meter hover above the Martian surface, touch back down to signal success, and then we can advance from there.
And getting back to what everyone's going to be looking at, you had mentioned that Hovard is going to be looking at a plot. What exactly is that going to look like? Is it easy to see if the flight actually took place?
Yes, so his altimeter plot will indicate a peak, and we'll start off with a flat line indicating that we were grounded. Then we'll spin up and it'll have a steep incline to show that we've risen. And then at the top we'll have a dwell where we're hovering, and then another steep decline in the graph to show that we've touched down. So it should be pretty cut and dry to see that we have successfully flew.
And this morning, of course, as you mentioned, the helicopter flew a few hours ago, and we're waiting to see if it did happen. But you did a whole lot of testing here on Earth before you sent Ingenuity up there. Tell me what it was like to test the helicopter and simulate that Mars environment.
Absolutely. So it went just because the helicopter is the first of its kind. The testing also is very similar in that way. We had to simulate a Mars-like atmosphere by using very large thermal vacuum chambers to allow us to control the temperature and pressure so we can simulate a Mars-like atmospheric density. Then we also created a gravity offload system that compensates for the difference in gravity between Earth and Mars. In addition to that, we validated a lot of our requirements with engineering models. So these are developmental models that we made, and they went through extensive environmental and aerodynamic testing. And so they were the precursors to our flight vehicle, which is, of course, currently on Mars.
And as Mimi mentioned before, it had to be super light and super fast. Why is that?
Flying on Mars is very difficult. You guys have heard it before. It's less than 1% of Earth's atmosphere, and that means that we have to have something really lightweight for us to overcome that mass to generate enough lift. And, you know, kudos and thank you very much to our friends over at Air Environment who designed and built this custom rotor system that is super lightweight. Each blade is less than 2 ounces made of composite material for that very reason. And it spans the distance. The wingspan of this helicopter is 4 feet tip to tip. So that's 1.2 meters. That's super large for something that's essentially carrying the size of a tissue box, just to give you a frame of reference. And in addition to that, generating enough lift involves having high RPM. So we're flying on an average of 2,500 RPM.
2,500 RPM. I just want everyone to sit with that for a minute, because here on Earth, helicopters go 400 to 500 RPM. So that is so much faster, Taryn.
It's incredibly fast, incredibly fast. Every detail on this vehicle is made and designed for it to be the most efficient.
You're beginning to see data products. We will continue to watch data products as the full set comes in.
All right, Taryn. Well, we just heard from Michael that they are taking a look at the data just starting to flow into the Deep Space Network antenna on Earth. What happens now that the rover has started sending that data?
Yes, so for those of you at home, the Deep Space Network is our giant communications network.
This is downlink. Early indications, data products look nominal.
Excellent. We'll continue to wait for the full data set to arrive. In the meantime, I'll explain a little bit about the Deep Space Network, and that it's our main communications tool to talk to our Ingenuity helicopter from across our solar system. So our downlink lead just announced that data products had just started to arrive and that they look nominal, which is a good indication. While we wait for the full data set to arrive, we'll wait. I guess that's what we'll do. We'll wait in the meantime.
And we'll answer another social media question along those lines. Jose on YouTube asks, how long does it take for the video signal from the helicopter to reach Earth?
Sorry, can you repeat the question?
Yes. How long does it take for the video?
So guys, they are receiving the data set from the flight. So this is a good news, and it seems that every data packet is nominal. So in their language, it is just like everything is positive. So they are just waiting to get all the packets back. So I mean all the data back from the rover. Let's see.
Hours from when something is executed to when we receive it. For larger files, though, sometimes that can take longer. So it all depends. But today we'll be receiving still images of the helicopter.
And I know we are eagerly anticipating those images. And we talked a little bit about this before, Taryn. We have been just floored by all the great images coming in from Perseverance, but Ingenuity has cameras as well.
Absolutely. The helicopter is equipped with 2 cameras. One is our onboard navigation camera, and that's the image that we'll receive tonight. And that's going to be a black and white image that's pointed straight down at the Martian surface and will hopefully be showing us hovering above it. Our second camera is our return to Earth camera, and that's our higher resolution camera that is a color photo and shows more of the Martian horizon snapshot, the beauty shot, if you will. And then and that image will be utilized for future flight missions.
And we have another great social media question here from Hing on Facebook asking, what is the biggest question this first flight will answer about aerodynamics on Mars?
Well, the biggest question that we had to answer when embarking on this was, can we lift? Can we generate enough lift and fly in a Martian atmosphere? And I think this first flight will indicate that for sure. And will answer that question. And whatever we receive back will definitely give us more information moving forward, regardless of this first flight or potential other outcomes.
And we've got another question on social. Wakia on Twitter asks, happy flight day. Why are the blades shaped the way they are?
That's a really great question. So in order to generate enough lift, each blade, I mentioned that these were custom designed, and what we call them are airfoils. And they're developed in a way so that it generates enough lift for us to fly and have enough thrust underneath of our helicopter vehicle. So they have that funky shape because of the aerodynamic elements that help it generate enough lift.
And once again, reminding everybody that you guys are controlling this from over 100 million miles away here on Earth. I always try to wrap my head around that.
Absolutely. It is so far away, and it's miraculous to even think that this is something that's technically already been executed earlier today. We're just kind of standing by and waiting for that data to arrive to indicate, success.
Well, we are going to have minimal commentary during this time as we're going to let you enjoy this experience with the team as they go through all the data to see how Ingenuity did. So let's head to the helicopter control room.
So guys, they are still waiting for the data packets, so let's wait and watch. So I will brief up from the start. So the flight actually happened like very before, like hours before. We are just receiving the data now, so let's wait and watch. Did the flight happen or not? Actually the flight happened but the distance between Mars and Earth is so much that it takes time to transmit the information from one place to another, like from the Mars to the Earth. So it's sometimes, as said by them, it takes hours if there is a large file, or if it is a small file, it can take up to like 20-30 minutes. Let's wait and see. And today we will get images, still images, and not videos. I think videos will be released later. Let's check back on that.
Link, data products appear to be in. We will begin processing shortly. This is Downlink. We are beginning to fetch data from Mars 2020. This is Downlink. We have pulled in data products from Mars 2020.
Guys, the data is in. They're just they have just begun to process it. Let's see. It's like you have written the answer in the exam. Now you are waiting for the correction to happen and the results day.
This is Downlink, confirming we received Mars 2020 telemetry, confirming that we received Mars 2020 events, confirming that we received helicopter data products, confirming that we have data products, confirming that we unpacked image and 1 Hz data. This is Downlink. We have successfully ingested 1 Hz data. Confirming that we have helicopter data products, helicopter telemetry, helicopter events. Confirming helicopter file listing. Confirming expected boot counts. This is Downlink, confirming battery data has been received.
Rotor motors appear healthy. Swash plate servos appear healthy. Overall actuators appear healthy.
Confirming thermal report generation. Confirming analog report generation.
So guys, everything looks normal. So you can see the head of the Ingenuity test on the left side from the start of the table. Like she's sitting there. She's very happy now.
Confirming telecom report generation. This is downlink handing off to flight control for telemetry analysis.
This is flight control, confirming that we have EVRs from Ingenuity. Ingenuity is reporting having performed spin-up, takeoff, climb, hover, descent, landing, touchdown, and spin down.
They did it.
And altimeter data confirms that Ingenuity has performed its first flight. The first flight of a
Guys,
powered
the first
aircraft
flight
on
on another planet has been done. It's a good news, very good news. I think we can expect the video. I think we can expect the images now, but I think the videos can take time, like a day or tomorrow. Let's wait for the images. Yeah, history is created. Guys, just see the images, Yes, what is going on is the Ingenuity helicopter took off from Mars. Like it actually took off from Mars hours before, but we got the data and the data is confirmed. So history is created today. We have autonomously
the Martian surface
controlled a flight.
Taryn, go ahead.
Yeah, we have autonomously controlled a flight on another planet. That's a great thing.
Oh, incredible!
And that's its shadow, right, Taryn?
Yes, that's its shadow. So the onboard navigation camera points straight down, so we're seeing its shadow right now.
I can just hear Mimi in the background. This is real. It's so amazing.
Yeah, everyone's really feeling it now. So we're gonna wait for the Perseverance rover image of us.
Guys, check back images. Yeah, it's coming. Oh, what's the video? I thought we will not get the videos today, but we have a Jiffy thing. She's so happy.
Are you guys seeing the Perseverance image?
Saw that, Taryn. So yes, explain what we just saw with the Perseverance image.
So the Perseverance image is showing us grounded at first. It's actually a video, which is great. It's grounded at first and then shows us hovering our 3 meters above the Martian surface and then touching back down. It's amazing, brilliant
Everyone is super excited.
So I would say it's a success. I would say.
Well, I got to tear up the contingency speech, which I never practiced, but I was going to read. But lucky for you, I have a much shorter speech for success. So, we can now say that human beings have flown a rotorcraft on another planet. So we've been talking so long about our Wright brothers moment on Mars.
She's giving the winning
And
speech.
here it is.
Victory speech.
And this project has had many friends who contributed to tonight's success. I see many in the room, the team in the room, the team on WebEx, team members who couldn't join us, and a few of our friends who are no longer with us. They're still in our minds today. And Perseverance Rover, the best host little Ingenuity could ever have. You know, history we don't know from history what Orville and Wilbur did after their first successful flight, the Wright brothers, but I imagine the two brothers helped each other.
She mentioned that
you know,
Wright
I'm
brothers
hugging you virtually,
from
and you guys
1902
haven't
to now.
been with me for 4, 5, 6 years. If it weren't for COVID-19,
Guys, it actually took 7 years to do this project, so they are very happy
so
for
this
this.
is all
I
I
know.
can do. I'm giving you the hugs. Look, we together flew at Mars, and we together now have our Wright brothers moment. So, you know, history does tell us that soon after that first flight, Wilbur and Orville did go right back to work. They flew 3 more flights that day, higher and further than the first ones. So we know, you know, like the Wright brothers at Kitty Hawk, we know that our time to make a difference at Jezero Crater, Mars is not yet over. This is just the first great flight. So let's enjoy this moment. But we must enjoy this moment because over the years, and there are a few of you especially, but there's some that have never let me celebrate fully. Every time we hit one of these major milestones, not yet, not yet. We'll keep moving on. So we must take a moment to celebrate this moment. Really important. Congratulations, everybody. Congratulations. Take that moment, and then after that, let's get back to work and more flights. Congratulations.
Congratulations to the Ingenuity helicopter team on making history this morning. To get the latest updates on Ingenuity, follow on @NASAJPL on Facebook and Twitter. I'd like to thank everyone for joining us at this early morning hour. The journey on this month of Ingenuity continues. Join us for a news briefing later this morning at 11 a.m. Pacific Standard Time for a deeper analysis of Ingenuity's first flight and what this means for NASA. I'm Marina Jurica. Thanks for watching, and good night, and go Ingenuity!
Congratulations to NASA, JPL, and all the human beings. So guys, everyone joining now. So whoever have missed it, so let me brief you. So the flight was performed on Mars like hours before. We got the data now, and it is a successful. The mission is successful. We have created the history. This is the first flight on any other planet which was so successful. Now you can see the video of the this thing they're just sending us. Can you see that? It's so good. It's so good. So what does this mean? This means that we are ready to go to Mars, and also when we go to Mars, we will not be just going on like the will not be just so it's same like you will fly on Earth from place to place, but you can do the same on Mars because this test was just to prove the same fact that we can fly on Mars. It will take some technological developments because this was just a prototype, so small prototype. We wanted to just see, and as said by them, on Earth the helicopter spin at a rate of 500 rpm, but for Mars, as there is no atmosphere, like there is atmosphere, but it is so thin that we provided an extra rpm of 2500 around that thing, so it's huge. So this is actually this this will be remembered, this day will be remembered, guys, because just think, after 20-30 years when you go to Mars and you are flying on a helicopter or something, you will be you will remember this day that you actually saw this test. So let's recap. Let's see let we will see that video of the Mars Ingenuity thing. I'm searching for that, one sec. What's this? It's my guarantee you will see like the Ingenuity post or in YouTube feeds for 1 or 2 months straight. YouTube recommendation will kill you for this. Instagram memes will be flooded.
Martian surface.
Taryn, go ahead and repeat that.
So the image we're looking at on the screen is the image from our onboard navigation camera showing us hovering above the surface of Mars. How incredible!
And that's its shadow, right, Taryn?
Yes, that's its shadow. So the onboard navigation camera points straight down, so we're seeing its shadow right now.
I can just hear Mimi in the background. This is real. It's so amazing.
Yeah, everyone's really feeling it now. So we're gonna wait for the Perseverance rover image of us.
Yeah, what's this?
Are you guys seeing the Perseverance image?
Saw that, Taryn. So this morning at
Yeah, the last one. See over. Wow. I think we'll get a clear video by. I think they will post it on this thing. So congratulations, NASA. So thank you for joining, everyone. If you want to watch the stream back, you can play it back. So last summary. Before that, I just want to say that tomorrow it is Tuesday, so I will be posting my new space news video It will be around in the afternoon. So please watch it. And also, if you are not subscribed till now, please subscribe, like, and share the video. So about the Ingenuity, it's a history. So I was following it for some like months, and today we all got to see the mission. It's so much fun. I think the mission people they are so happy about it. So this is an history created today. I think we will they have some 30 Martian days time for this. I think if I'm not wrong, it's 30 Martian days. Let's check back on that. So I think they will perform some more tests. Now they have just tested to see the rover, if it lifts it, then if it hovers, then it come back to the ground. So let's see the future test. So but this is a very positive sign. Actually, this is great. This is truly great, because now the NASA has announced the moon mission. Like SpaceX has been awarded the contract. So I think from that stage, after the Artemis is completed, next I think everyone will be heading to the Mars. So Elon Musk dream. So I think we can take a car and an helicopter now. Elon's Tesla is already roaming in space. Let's see about that. So this was the live stream for the Ingenuity Mars helicopter. Thank you for joining, everyone. So I think I will end it. I will be staying here. If anyone has any, like, if you want to do some time pass, I can, or you can, if you want to ask anything, then hit me up on the chat box. I will try to solve that. Have a nice day. Guys, I will be staying here. We will just do the recap of the movement. It's fun watching that scene. So let's say. Again, thank you for joining, everyone. This has been a great stream for me. This is my second stream, so it's going well. I don't know. Yeah, of course. Also, another news. I think the Crew 2 mission is going to be on 22nd of April. I think that is on Wednesday. I will let you know the stream timings, and please join back on that day too.
Telecom report generation.
Yeah, the same.
This is Downlink handing off to flight control for telemetry analysis. This is flight control confirming that we have EVRs from Ingenuity. Ingenuity is reporting having performed spin-up, takeoff, climb, hover, descent, landing, touchdown, and spin down.
Everything went well. Everything went well.
And altimeter data confirms that Ingenuity has performed its first flight, the first flight of a powered aircraft to another planet.
The Martian surface.
Taryn, go ahead and repeat that.
So the image we're looking at on the screen. Are you guys seeing the Perseverance image?
Saw that, Taryn. So yes, explain what we just saw with the Perseverance image.
So the Perseverance image is showing us grounded at first. It's actually a video, which is great. It's grounded at first and then shows us hovering our 3 meters above the Martian surface and then touching back down. It's amazing, brilliant. Everyone is super excited.
So I would say it's a success. I would say.
I got to tear up the contingency speech, which I never practiced, but I was going to read. But lucky for you, I have a much shorter speech for success. So, we can now say that human beings have flown a rotorcraft on another planet. So we've been talking so long about our Wright brothers moment on Mars. And here it is. And this project has had many friends who contributed to tonight's success. I see many in the room. The team in the room, the team on WebEx, team members who couldn't join us, and a few of our friends who are no longer with us. They're still in our minds today. And Perseverance rover, the best host little Ingenuity could ever have. You know, history doesn't. We don't know from history what Orville and Wilbur did after their first success.
Thank you guys for joining the stream. That's the end of this stream. So don't forget to watch my video tomorrow. So I think I will release the video in afternoon somewhere. Watch the space news. I will add this news too. Let's also join back on 22nd. We will witness the crew too. I will be doing the same live stream there. So thank you for joining. This has been a great stream. History made today. It was a good day. So thank you. Have a great day. Like, take care, and please take care of yourself. Thank you.
Mr. Buchan. Sorry, can you repeat the question?
The team as they go through all the data to see how Ingenuity did. So let's head to the helicopter control room.
This is downlink. Data products appear to be in. We will begin processing shortly. This is downlink. We are beginning to fetch data from Mars 2020. This is downlink. We have pulled in data products from Mars 2020. This is downlink, confirming we received Mars 2020 telemetry, confirming that we received Mars 2020 events, confirming that we received helicopter data products, confirming that we have data products, confirming that we unpacked image and 1 Hertz data. This is downlink. We have successfully ingested 1 Hertz data. Confirming that we have helicopter data products, helicopter telemetry, helicopter events. Confirming helicopter file listing. Confirming expected boot counts. This is downlink confirming battery data has been received.
Battery data looks healthy.
Rotor motors appear healthy. Swash plate servos appear healthy. Overall actuators appear healthy.
Confirming thermal report generation. Confirming analog report generation. Confirming telecom report generation. This is downlink handing off to flight control for telemetry analysis. This is flight control confirming that we have EVRs from Ingenuity. Ingenuity is reporting having performed spin up, takeoff, climb, hover, descent, landing, touchdown, and spin down. And altimeter data confirms that Ingenuity has performed its first flight, the first flight of a powered aircraft to another planet.
The Martian surface.
Taryn, go ahead and repeat that.
So the image we're looking at on the screen is the image from our onboard navigation camera showing us hovering above the surface of Mars. How incredible!
And that's its shadow, right, Taryn?
Yes, that's its shadow. So the onboard navigation camera points straight down, so we're seeing its shadow right now.
I can just hear Mimi in the background. This is real! This is real! It's so amazing.
Yeah, everyone's really feeling it now. So we're gonna wait for the Perseverance rover image of us. Are you guys seeing the Perseverance image?
Saw that, Taryn. So yes, explain what we just saw with the Perseverance image.
So the Perseverance image is showing us grounded at first. It's actually a video, which is great. It's grounded at first and then shows us hovering our 3 meters above the Martian surface and then touching back down. It's amazing, brilliant. Everyone is super excited.
So I would say it's a success. I would say.
I got to tear up the contingency speech, which I never practiced, but I was going to read. But lucky for you, I have a much shorter speech for success. So, we can now say that human beings have flown a rotorcraft on another planet. So we've been talking so long about our Wright brothers moment on Mars. And here it is. And this project has had many friends who contributed to tonight's success. I see many in the room. The team in the room, the team on WebEx, team members who couldn't join us, and a few of our friends who are no longer with us. They're still in our minds today. And Perseverance rover, the best host little Ingenuity could ever provide. You know, history we don't know from history what Orville and Wilbur did after their first successful flight, the Wright brothers, but I imagine the 2 brothers helped each other. Well, you know I'm hugging you virtually, and you guys haven't been with me for 4, 5, 6 years. If it weren't for COVID-19, you guys don't have a chance of me. So this is all I can do. I'm giving you the hugs. Look, we together flew at Mars, and we together now have our Wright brothers moment. So, you know, history does tell us that soon after that first flight, Wilbur and Orville did go right back to work. They flew 3 more flights that day, higher and further than the first ones. So we know, you know, like the Wright brothers at Kitty Hawk, we know that our time to make a difference at Jezero Crater, Mars is not yet over. This is just the first great flight. So let's enjoy this moment. But we must enjoy this moment because over the years, and there are a few of you especially, but there's some that have never let me celebrate fully. Every time we hit one of these major milestones, not yet. We'll keep moving on. So we must take a moment to celebrate this moment. Really important. Congratulations, everybody. Congratulations. Take that moment, and then after that, let's get back to work and more flights. Congratulations. happy now? That's my other favorite picture. Yes, my real favorite picture.
If you play that on loop, yeah, they're playing on loop.
Congratulations to the Ingenuity helicopter team on making history this morning. To get the latest updates on Ingenuity, follow on @NASAJPL on Facebook and Twitter. I'd like to thank everyone for joining us at this early morning hour. The journey on this month of Ingenuity continues. Join us for a news briefing later this morning at 11 a.m. Pacific Standard Time for a deeper analysis of Ingenuity's first flight and what this means for NASA. I'm Marina Jurica. Thanks for watching, and good night, and go Ingenuity!